The raffle box every 30 minutes. So you have a chance every 30 minutes to potentially win $50 and a gorgeous new t-shirt. So our next Chem demo comes from University of San Diego Chem Club. And let me go ahead and invite them on stage. They're coming up right now. And they've got some really cool experiments as well. Carbon snake. Or rainbow indicator and get a good vlog on there. Rainbow? Today we're going to give you a little presentation in 3 acts. So in our first act, we're going to take you on a journey to the nanoscale. All right, meter.
I am right.
Okay, so basketball player Shaquille O'Neal is 7 feet and 1 inch tall. That's 2 billion nanometers. Well, we measure our height in meters. Okay, who's next? Decimeter. All right, a human hand is 100 million nanometers long. Horses' height, for example, thoroughbred horses are measured in hands. 1 hand is about 1 decimeter. All right, an ant, if you guys ever studied entomology, is 5 million nanometers long. An ant is about 1 centimeter. Also, a strand of hair is about 100,000 nanometers wide. This is 1/10 of a millimeter. Yep. Okay, micron. Alrighty, so if you're not into entomology, perhaps you're into virology. A bacteria is 1,000 nanometers long, and this is called the micron size scale. The unit that we use to measure this is a micrometer. Alright. Yes, nano. We're nano. We're at the nano scale. So, a typical protein such as hemoglobin, this is the protein that carries oxygen in your bloodstream, is 5 nanometers in diameter. And a water molecule is about 1/2 nanometer. That little thing? Water molecule is about 1/2 nanometer. All right. So that concludes Act 1. Now that we're down to the nanoscale, what are we going to learn about? we're going to learn about functional fabrics and how nanotechnology has enabled us to have clothing that is functional and beautiful. So is anybody out there wearing running shoes? Running shoes. Come on, Mom. Come on, Mom. Strut, girl. Come on, it's all right. Okay. The ion mask is a nanoparticle technology used in Nike running shoes. The ion mask reduces the amount of water absorbed into the shoe and increases the amount of evaporated perspiration allowed to flow out of the shoe. All right, raincoats. Raincoats make the use of nanoparticles to create a water-repelling finish. Certain coats are finished with a layer of silicon nanofilaments, which are naturally hydrophobic, meaning that fabric coated with silicon will remain unaffected even in the presence of water. Where's my pants? Nobody's wearing the pants. So these pants actually are coated with a Teflon coating. Teflon is another way to create a hydrophobic surface to resist stains and water. The material Scotchgard was actually invented by a woman. Patsy Sherman spilled this substance on her shoe and nothing could get it off. And that's how Scotchgard was discovered. The other interesting material that was invented by a woman is Kevlar. Yes. Kevlar is also in these pants, for whom I could not find a model. Kevlar is in the knees of these pants. These pants were actually obtained at the Los Angeles Police Department Police Academy. And they have Kevlar in the knees, so that when the men and women of our different protective services are working and they need to kneel down to do their job, they don't get a hole in their pants. So, the reason why Kevlar, take your wall. The reason why Kevlar is so strong is because it's 5 times stronger than steel, because the fibers are aligned by spinning when the polymer is formed from solution. The Kevlar monomer is polyparabenzamide. And as I said, the knees of the pants that are worn by police officers and other law enforcement contain Kevlar, in addition to bulletproof vests, which they would not let me borrow. All right. Ah, it's falling. You next. All right, so in our final ensemble of Act 2, we have nanoparticles, which are embedded in fabrics to prevent odor, because silver nanoparticles actually prevent the formation of bacteria. Silver nanoparticles are also found in the containers that hold your leftovers, in your refrigerator, in your air conditioner, and many other places in the home. All right. Nice. So finally, let's conclude this nano fashion show by Act 3. In Act 3, we're going to learn about the properties of matter at the nanoscale. So one thing, for example, is sunscreen. Sunscreen contains nanoparticles of zinc oxide and titanium dioxide. And instead of having a white chalky sunscreen on your face, nanoparticle sunscreens are actually completely see-through. So perhaps all of us are wearing it and you wouldn't even know. All right, carbon fiber. Okay, this is a bracelet. Bam! Work it. Okay, carbon fiber is made entirely out of carbon, and it's used in applications where lightweight and durability are important. It's much lighter than metal of the same strength. And yes, carbon. That's a carbon nanotube. So carbon fiber is used in aeronautics, in automotive applications, and yeah, spaceships and stuff, racing bicycles, tennis rackets, and other items where strength and lightweightness are very important. Alrighty, now next we have another household application of nanotechnology, The encapsulation of odor by beta-cyclodextrin. Beta-cyclodextrin is a cage molecule. Cage molecules can entrap odors and remove them from your clothing or your carpets. And beta-cyclodextrin is the active ingredient in the household product Febreze. Okay, sunglasses. Let's do a double. Okay, sunglasses employ nanotechnology. They're actually oftentimes coated with a molecular substance where the molecules align in a certain direction and they only allow light of a certain polarization to hit the eye. So most of the light, reflected light, comes from horizontal surfaces, and your polarized lenses are going to be polarized such that they only let vertically polarized light into your eye, and they absolutely reflect any horizontally polarized light. And as second to last of the properties at the nanoscale, we're going to demonstrate the ability of surfaces to adsorb molecules. So in this hat, we have a surface that has molecules adsorbed to the surface. And a lot of times at the nanoscale, we use a technique called scanning tunneling microscopy, where a tip that is basically 1 atom wide is used to go over the surface to characterize its roughness or features, surface features. So this is trying to show you how scanning tunneling microscopy may look if you could have a microscope so that you could see at the nanoscale. And in our last ensemble of properties at the nanoscale, we have reflective material. You got it. So many reflective materials can be used to protect you if you want to be outdoors and out and about at night or in the daytime. In the daytime, it's recommended that you wear something that has a fluorescent dye in it, and at night it's recommended that you wear some highly reflective material. And reflective material comes in retroreflective or another type of coating. So this is an example of retroreflective material, and it's the properties at the nanoscale which really allow this material to reflect light back to the driver, keeping you safe. You can actually be prevented from getting into an accident or anything. It will help the driver see you 3 seconds faster. 3 seconds faster. Thank you for the nanoscale fashion show. Let's give a hand to all of our models. Tell us your names.
Sydney, Vicky, Mandy, Beth, Victoria, Jaya,
Roxana.
All right, let's give our models a hand. That's it.
Good job, please.